So, hi everyone, welcome back. Welcome to this third video of this fantastic horn antenna course. I am Claudio from L&S Academy, and this is your horn antennas course. So today we are going to continue talking about designing. Let's go for the designing, and today we are going to model, we are going to simulate a pyramidal double reach aperture horn. Let's say that this video is just an evolution of the previous one. So for this pyramidal double reach aperture horn, we got the same electrical specification, just to make it easier to explain and to make it easier to follow. Therefore, the frequency band would be from 2 up to 6 gigahertz, and we got an S11 requirement below minus 10 dBs. And as we said in the previous video, this criteria is a good criteria, a good way to, let's say, to be sure that our antenna got a good matching in this frequency band. We are going to talk about gain, about azimuth and elevation width, but for this case we got to take into account that we are designing a double reach aperture horn. Okay, so with that said, we are going to follow the same skeleton that the previous one. So preliminary information, we please make sure to watch the first video where we give you some comments, where we comment different aspects, some important topics related with this kind of horn. So please make sure to check it out. Then the second point is that we are going to continue using CST Studio Suite 2017. And goals are the same as the previous one: CST familiarization, parametrization of the horn, defining in a professional way, and we will talk about optimization and about the main antenna parameters. Okay, so what you should know about this kind of antenna, about double reach antenna? Well, the first point is that inserting reach in E plane of a waveguide lowers the cutoff frequency compared to a typical waveguide with the same width. Okay, in other words, remember that, as we said in the introduction video, a good way to enlarge or to make it wider our bandwidth is by inserting reaches inside our waveguide and inside the aperture, as you can see in the figure below. This is a good technique to enlarge or to expand the frequency band, okay, of our antenna. So the second point, and it is related with the third one, we said that with using reached we can lower the cutoff frequency, and at the same time we are able to raise the cutoff frequency of the next two higher modes. With that, we can produce a waveguide that operates over a obtain one frequency range or more. And last but not least, if we use this as an input waveguide to a horn and a taper, they reach until they not block the horn aperture. The horn radiates a pattern similar to the smooth wall horn. This is another type of horn. You can Google it if you want, just to make sure that you have a clear vision of a smooth wall horn. Okay, so design process. Okay, I got to say that I will take the CST file from the previous video, so make sure to follow the previous video in order to have the basic solid of a horn antenna that we already commented and that we explained in the previous video. Just to get this, okay, this is where we leave it in the previous video. We got our well parameterized horn, okay, pyramidal horn in this case, and we could change whatever we want from this horn, actually, because we got a good parameterization of our horn. So before starting, a good point that I would like to highlight is that I made some optimization for this frequency band, and I would recommend you to set these values for our parameters. Okay, this is for the waveguide, width, length, and height. Metallization, we keep in 2 millimeters. Then we got the flare and the aperture width, and also the height of the aperture. Okay, this is just a recommendation in order to get a better horn performance of your horn. Okay, but you can play with it. Okay, so the advantage of continuing with the previous project is that we already talked and we already explained how to create a high frequency, define our frequency range, background. We talk about boundaries, about background in the previous one. We also define field monitors. We talk about waveguide and some recommendation. This is a link you must check it out, okay, just to make sure. Then we build our waveguide solid, everything made in perfect electromagnetic conductor material, aperture brick. We copy that solid, then we apply some Boolean operation, and then we subtract the solids in order, just to remember, in order to obtain the cavity of our horn. Okay, so for this video, what we are going to do is to define and to talk about how to build and how to parameterize the double reach that basically is the topic of this video. So we will explain how to define it using some curves, and what advantages, what disadvantages we get, and much more. Okay, so step 6, before everything, we got to define, as you can see here, we got different parameters, so we had to add to our parameterization section. And for that we are going to go to CST, okay, and here we can introduce different parameters as reach height, okay, and that's all. Waveguide, yeah, I think this is all for the moment. Okay, yeah, the height will be 3 millimeters for the moment. Okay.